Hello, our purpose of the day is I can solve quadratics by factoring and graphing. We are going to look at graphing quadratics and specifically if roots are not integral. So what does integral mean? Integral means integer. So this means we are going to have solutions to our quadratics that aren't necessarily an integer. They're going to be a decimal answer, or we might have a fraction answer. So let's look at first if we could factor this quadratic equation to solve for our roots. So I would use the diamond method, and I would ask myself what are factors of 2 that when added together give me -4, and there aren't any, so we can't factor this, but we still may have a solution. So let's find the axis of symmetry, vertex, and y-intercept, and let's look and see what our graph of our parabola looks like. Axis of symmetry, again to remind you, is opposite of b over 2a. So I have here 4 over 2 times 1, which is 4 over 2, which means my axis of symmetry is at x equals 2. Now I want to find my vertex, so I'm going to plug in 2 into the x-coordinate of my quadratic function and solve for y. So here I have 2 squared minus 4 times 2 plus 2. So 4 minus 8 plus 2 is -2. So my vertex is 2, -2. Now I'm going to find my y-intercept here, and the y-intercept is found by 0, c, whatever c is, and c here is 2, so 0, 2. And again, I'll circle my important pieces here, and I'm going to go ahead and I'm going to graph this parabola over on my graph. Okay, so I've graphed my y-intercept, vertex, and axis of symmetry on my graph over at the right. Now, my parabola crosses the x-axis twice, so I have 2 solutions. However, I was unable to factor this quadratic to find my actual integer factor answers. So here where it says roots or x-intercepts, I need to actually approximate these x-intercepts if necessary. And here it's necessary because we know that they don't cross at an exact integer location. So I'm going to look at my graph, and I'm going to actually zoom in here. And I'm going to look a little bit closer, and I see that my parabola actually crosses the x-axis twice. So I'm going to approximate my 2 solutions on my graph. So the first one looks like it's at about, I would say about 0.6, so a little almost over halfway, and that the other on this side is about 3.2, so it's a little over 3. So my solutions that I approximate are 0.6 and 3.2. So again, I've approximated my answer, so x is approximately 0.6 and 3.2. Now, if you're off by a few tenths, that's okay, and that's fine. As long as you're somewhat close to the actual answer, you will be just fine. Okay, and let's continue to answer a few more questions about this parabola. So here I want to look, and I have a maximum or minimum, and for this problem, I have a minimum, and my minimum is at the y-coordinate of my vertex, which is -2. The domain for this function is all reals, or x is between -infinity and +infinity. And then my range, my lowest value that this graph can be, is at -2. So -2 is less than or equal to y, which is less than +infinity. So we just looked at a problem where we did not have integral roots, but we were able to graph our parabola, and we noticed that we did have 2 solutions. They were just decimal answers to our solution. Then we answered a few more questions about this quadratic. Now I have 3 more problems for you to practice at. I will go through the first one with you. Okay, let's take a look at this function. We are going to graph this function and tell a little bit more about it, and I'm guessing that we are not going to have integral answers, which means we will have answers that are perhaps decimals. So let's first get started by finding the axis of symmetry. Here, which would be opposite of b over 2 times a, which would be -2 over 2, which would be at x equals -1. Now to find the vertex, I'm going to plug in -1 and solve for my output y. So -1 squared plus 2 times -1 minus 9, and that is going to equal -10. So my vertex is at -1, -10. My y-intercept is my c term, so here would be 0, -9. And my x-intercepts, this is what I have to actually go ahead and find. I mean, I could go ahead and try to use the diamond method and find factors of -9 that would add it together give me 2, but there are none. So I'm going to have to use my axis of symmetry, vertex, and y-intercept and approximate my x-intercepts or roots and find my solutions. So now I'm going to zoom in on my graph and graph those important pieces of information of this quadratic. So I have graphed those important pieces of information. Now I'm going to look at my graph and I'm going to see what are those 2 x-intercepts, and I know I have 2 because my parabola crosses the x-axis twice, and they look like they're about at 2.2, so x is approximately 2.2, and I would say -4.2. So 2.2 and -4.2 are our solutions. Now let's answer a few more questions about this parabola. We have a minimum at the y-coordinate of our vertex, which would be -10. Our domain is all reals, so x is between -infinity and +infinity. And then for our range, our parabola opens up, so we know we're going to +infinity, and the lowest value is the y-coordinate of our vertex. So -10 is less than or equal to y, which is less than +infinity. So to recap, we found the x-intercepts, or solutions, to this quadratic function, and we didn't have integral answers. Again, they were decimal answers, but we were able to find those by, again, finding the axis of symmetry, vertex, y-intercept, and plotting those important pieces, and then estimating our solutions to the nearest tenth. Here are the answers to all 3 example problems. Please make sure you took the time to go through these and you got the practice that you needed to feel comfortable with this material. Again, feel free to take a look at this page as long as you need to make sure you have the right answers. And if you can notice, on the second graph, I did have to scale my graph to make sure I could fit all those points in and make sure I could get the correct x-intercepts to the closest estimate that I could get. Please check Google Classroom for your assignment, and thanks for listening. Have a great day.